Hello everyone, this is Venkat Bandi, and in this video I'll be presenting our research in developing a visualization platform for managing learning data in the field of academic medicine. This research work was done along with Debajyoti Mondal and Brent Thoma as a collaboration between the Department of Computer Science and Emergency Medicine at the University of Saskatchewan. In this research, we present a dashboard that was designed for managing the training data in the context of academic medicine, where the learners are resident physicians and their educators are certified doctors. In today's world, data visualization systems are increasingly being used to analyze educational data and learners' behavior. Most online learning management systems, in fact, integrate dashboards such as the one shown here to help learners understand the performance and educators to review the learner's progress and needs. In such learning environments, learners share a common learning plan and often the performance is visualized relative to each other. And while much effort has been invested in understanding the scope of visualization in such structured format courses, the usefulness or the need of visualization in the context of professional training is less explored. These professional training environments are different because training here is often unstructured or semi-structured and scheduled around the needs of an individual learner. And a large part of the training may also rely on personal observation-based assessments. Also, while overall performance between learners can be compared, in most contexts, comparison among learners may not be meaningful due to the unique training plan of every individual learner. This motivated us to examine whether visualization systems can still be used to assess the learners and their educators in such a complex scenario. One particular example of such unstructured learning environment is the professional training of resident physicians in academic medicine and is the primary focus of this research work. The main goal of our project was to build a visualization platform that can be used in the complex semi-structured learning environment of a resident physician's training. Now, to get more background context, a resident is a medical physician undergoing training, often in a specialized field. During the training, they're progressively promoted based on their performance through 4 major phases before they finally graduate. These phases are called the training phases, and the decision to promote residents is made by a panel of senior physicians who are referred to as simply reviewers. Also, every academic year, residents go through a unique personalized 13-block schedule where they're assigned to different departments to gain diverse clinical exposure, and every block is a rotation. One of the key ways in which residents are assessed is by EPAs. EPAs stand for Entrustable Professional Activities and are defined as tasks that a resident can be entrusted to perform to demonstrate competence. They often include a resident taking care of a patient or a medical situation under the supervision of a senior physician. The senior physician then rates the resident on a 5-point scale where 5 is the best, meaning the resident took care of the situation by himself, and 1 is the worst, where the senior physician had to step in. Now, this training methodology for resident physicians has been in use across all major medical programs in Canadian universities and is currently managed through a system of textual reports as shown here, and this makes the need for a visualization-based approach all the more evident. The design of our system was developed through 4 focus group discussions with the residents and several individual meetings with reviewers, and the final goal was to develop a common visualization dashboard that can be used by both to track a residents' academic progress. Our visualization system consists of 2 main interactive views. The first of which is the personalized resident view, which can be used by both residents and the reviewers to track the performance individually. And the second is a normative review view that can be used to compare certain summary metrics of residents relative to others in the learning program. This still doesn't compare the individual training plan itself, but rather looks at top-level metrics of all residents in the program. This view, in combination with the resident view, offers reviewers a multifaceted approach to analyze a resident's learning progress. Now, the resident view in particular is a complex dashboard consisting of multiple submodules, each designed to answer one particular question about a resident's learning progress. The first of which is the rotation schedule. In a given academic year, this module shows the medical department or rotation the resident is currently working in at the moment, and the rotations he worked in before and will work in the future. Additional information about the resident's performance in each of the rotation can be toggled on and off and consists of a color-encoded panel showing if a resident is meeting the required number of observations in that rotation, and rotations in which requirements are not met get highlighted in red. The second part of the dashboard looks at each of the individual EPAs acquired by the resident. Here, to tackle the problem of information overload, we group EPAs into the 4 major training phases that a resident must go through. Each of these phase blocks can be expanded by clicking on them, which in turn shows all the EPAs in that phase in a tabular fashion, ordered by the EPA number. Once investigation of EPAs in a phase is complete, the phase block can then be clicked again to hide the EPA list. For each EPA in that list, description and summary statistics is shown along with a bullet chart to indicate what percentage of observations are still required by the resident to demonstrate competence in that EPA. And finally, all the observations made for that EPA are visualized in a time series chart over the 5-point rating scale. While we visualize the essential information in a simple chart, we do provide the ability for more complex investigations through advanced filters that can be activated through user interactions. For example, if a user wants to find out if a resident has completed observations of a particular medical scenario, a patient demographic, he can turn on a selection filter and select the required scenarios. All observations that match these are then highlighted in red. This encoding can be further combined with a date filter to look for observations that were completed in a particular time period, where these records turn into diamond-shaped points instead of circles. In this way, we can use a combination of color and shape encoding for more advanced filtering scenarios. To validate our system, we deployed a stable version of the visualization dashboard online for the Department of Emergency Medicine at our university and provided access to both user groups consisting of 16 residents and 6 reviewers. And we measured the user logs for a period of 4 months. We were primarily interested in examining the change in usage pattern as an indicator of whether the users found the system useful in real-life decision making. We also compared the EPAs acquired by residents during the study period with EPAs acquired by them in the previous year in the same period to quantify the change in key learning metrics brought about by the introduction of our system. We first looked at the number of visits made by the different user groups to the visualization system and noticed nearly consistent usage by residents and 2 major peaks in the usage for both groups, which coincided with the quarterly review meetings done to assist residents. This usage pattern shows the organic engagement that different user groups had with our system and is in line with comments made by residents during the discussion session, where they mentioned that they use the dashboard more frequently to track their progress and plan for the future, while reviewers only use the dashboard during review meetings to assess the residents. Then, we looked at the change in 4 key metrics after the adoption of our system and found positive improvement in 3 of them. The rate at which residents acquired EPAs in each medical department improved by 12% and the amount of feedback given increased by 22%. Further, the rate of expired EPAs that were initiated by a resident but never completed dropped by a drastic 45%. All 3 changes indicate that through constant review of our observations in the dashboard, residents were able to get consistent and better quality feedback and improve upon it. This evaluation proves that visualization systems can be developed even for unstructured learning environments to assist diverse user groups. While a natural limitation of our work comes from exclusive focus on just one medical department during the design and evaluation of the study, we've recently extended our visual platform to other medical programs within our university, such as internal medicine, pathology, neurosurgery, and obstetrics. And several other programs across Canada have shown interest in adopting our dashboard. This large-scale adoption of our system opens up new avenues to examine the usage pattern with a larger number of users across different programs. Also, a significant byproduct of aggregating several records is that dashboard can now be modified to visualize the performance of the training program itself. While our system is just the beginning, we believe that our work will improve further visualization research in developing a generalized approach for other such similar professional training scenarios.